Hey math enthusiast, I'm here to continue the notes about special right triangles, section 7.4. And in this video we're going to take a look at the 45, 45, 90 triangle. So first let's just recall what we know about right triangles. Well, based on what we talked about before, I know that if I take a leg squared plus a leg squared, it's going to equal the hypotenuse squared. So in this case, C would be my hypotenuse, A and B would both be legs. Now, what if I told you we had some more information about this triangle and I actually knew that a couple of the angle measures besides the 90 were 45 and 45? So how does that change things? Well, that means if I have two angles that are congruent, I'm going to have two sides that are congruent. I'm not quite sure what the side lengths are, but let's just say they're both x. So now for my equation down here, instead of saying leg squared plus leg squared, I can say x squared plus x squared equals hypotenuse squared. Now, I'm not quite sure what the hypotenuse is, so I'm just going to keep this as hypotenuse squared. Now, in this specific case, these two are actually like terms. So I can add them up and I'll get 2x squared equals hypotenuse squared. Now, the question is, well, what is the hypotenuse? Well, in this case, since I combine these two terms, x squared and x squared, I can take the square root on both sides. Now, what's going to happen when I take the square root of 2x squared? I'm going to end up with square root of 2 times square root of x squared equals the hypotenuse, because that square root is going to cancel out that 2. Now, in this case right here, square root of x squared, well, they're also going to cancel out, and that's just going to become x. So now I know the hypotenuse is just going to be whatever x is times radical 2. So I can complete my picture up above and say that the hypotenuse is actually x radical 2. And this will always be the case for any 45, 45, 90 triangle. So this picture that they give us on the right should look familiar. It's pretty much the exact same picture I just drew. And for this 45, 45, 90, I know that the hypotenuse is square root of 2 times as long as each leg. So if I'm looking to find the hypotenuse, all I have to do is take one of those legs, whichever one, and multiply it by radical 2. Now, if I'm looking for a leg, that means I have to do just the opposite. So I got to figure out what exactly is this x value in front of that radical 2. Well, that x is being multiplied by radical 2. So what I'm going to do is I'm going to take that hypotenuse, whatever value it is, and I'm going to divide it by radical 2. So these are essentially the two rules I need to know to figure out my missing parts depending on what I'm given. So for this first example, it looks like we have 90 down here, 45 here, so that means this last angle has to be 45. And I know that to be true because both of these sides, 2 radical 2, are the same length. So what I'm looking for is the hypotenuse. And what I said earlier, to figure out the hypotenuse, what I'm going to do is I'm going to take a leg and I'm going to multiply it by radical 2. So I have the length of each of my legs, so let's plug that in. So it's going to be 2 radical 2 times radical 2. Well, I can't do anything with this 2 on the outside. That's going to stay the same. But with the radicals, I can multiply them together. So we have radical 2 times 2, which is going to give me 2 times radical 4. Radical 4, that's actually 2. 2 times 2 gives me 4. So my final answer in this case for x is 4. Now it looks like for example 5, my two legs here are the same length, x and x, which means I'm dealing with the 45, 45, 90 triangle. Now this one's a little different than the previous example because I'm given the hypotenuse and I'm trying to figure out, well, what is the length of each leg? So remember what my equation was to take the hypotenuse, whatever it is, and divide it by radical 2. Alright, so in this case, I'm given my hypotenuse. I know that it is 9 radical 2. Now, since we have a radical 2 in both the numerator and denominator, I can cancel those two out, and I'm just left with 9. So in this case, I know x equals 9. Both my legs have a length of 9. Now, this one wasn't too hard because the way the hypotenuse was written out, 9 radical 2, I know that since the rule says the hypotenuse is x radical 2, that 9 must equal x. But some of them are not as obvious. So for example 6, it's very similar to the previous example. My two legs are the same length, x and x, so I know I'm dealing with the 45, 45, 90. The one side they do give me is the hypotenuse, but in this case there is no radical 2 to go with it. So let's remember what our equation is. So if I want to figure out what a leg length is, I'm going to have to take the hypotenuse and I'm going to have to divide it by radical 2. So let's replace the hypotenuse in my equation with the actual hypotenuse in this problem, which is 2. So in this case, the radical does not cancel out as easily. So this is just like the first three examples I had where I had to rationalize the denominator. So in order to get that radical out of there, I'm going to multiply the whole fraction by 1, but I'm going to disguise it as radical 2 over radical 2. I'm specifically choosing this because now in my denominator, I'm going to end up with radical 2 times 2. In the numerator, unfortunately, it's just going to remain 2 times radical 2. But now in my denominator, I'm going to end up with radical 4. Well, the square root of 4 is actually going to change to 2. And in my numerator, I have 2 radical 2. Now, once again, it looks like something can cancel out here. The 2 in front of the radical and the 2 in my denominator cancel out, which just leaves me with radical 2. So the length of each of my legs, the value of x, is radical 2. And for my last example, it looks like I have a right triangle. We have 45 for one angle, which means my last angle is 45. So I know right away that these two side lengths are congruent, so that means this side is 25. But what they're asking for in this problem is the hypotenuse. So in order to find the hypotenuse, what I'm going to have to do is I'm going to have to take one of the leg lengths and I'm going to have to multiply it by radical 2. So in this case, let's plug in one of my legs. Doesn't matter which one because as I said, they're both the same. So it looks like the hypotenuse in this case, or we can say x, is equal to 25 radical 2.